Okay, in this section we're going to get into the definition of your trig functions. And as it states there at the top, if theta is an angle in standard position and the point xy is any point on the terminal side other than the origin, then the 6 trig functions of the angle will be defined as follows as we go down through here. Alright, so go into over here, this is your x and your y axis. Okay, so we're going to be drawing this off with it being obviously in the first quadrant, but you could apply this to other quadrants. Now it mentions about it being in standard position, so I'm just going to pick this as being my terminal side. So from here to here is going to be my theta. Now it refers to picking a point on the terminal side. So I'm just going to randomly pick this point. So that's this point xy. Okay, so if we were to draw a triangle, a right triangle, of course from here to here would be my x distance. From here to here would be my y distance. Now the distance, which would be your hypotenuse from the origin to this point that's on the terminal side, we're going to refer to as r. If you remember back in the previous section when I gave you the formula for the distance formula, instead of having d equal, we had r equal. Okay, this is where we're going to start seeing the r, and I'll explain a little bit more about that actually on the next slide that I have here to show you. I'll tell you more about r. Alright, so all this is going to be in reference to theta. Alright, at the top, of course, the spelling of sine, and then this would be the abbreviation. So if you're wanting sine of angle theta, so if you want sine of this angle, it's always defined as being y over r. So it's going to be this opposite side over this hypotenuse. And I know you learned in geometry about opposite, adjacent, and hypotenuse. So this is the basis is exactly the same. It's just we're using x, y, and r since we're looking at this on our coordinate system. Okay, cosine. So cosine of this angle would need to be this side, which is also referred to as adjacent side, divided by the hypotenuse. So that's always going to be x over r. Tangent of this angle will be y over x. Okay, and then going to cosecant. Cosecant is going to be r over y. Secant is going to be r over x. And cotangent, scoot it up here a little bit, cotangent will be x over y. Now you'll notice that these pair up like as far as reciprocals, like for instance your tangent and your cotangent, the definition that you're given here for that, those ratios are just reciprocals of each other. Same thing is true for your cosine and your secant. Those are reciprocals. And let me bring it back down, and then if you compare your sine with your cosecant, see, those are also reciprocals of each other. Okay, so this bottom statement that I have here says the 6 trig functions are simply names given to the 6 possible ratios that can be made from the numbers x, y, and r. So ratio meaning a fraction. If you just start making all the different fractions that you can make using these 3 variables, you can only come up with 6 different fractions, 6 different ratios, and that's what these trig functions are. So the ratios, or the fractions that I've set each of these equal to, are the only possible 6 that you can get from this. And they've just randomly assigned them the names of sine, cosine, tangent, cosecant, secant, and cotangent. Okay, next is where I have a little bit more information for you about r. Okay, so it states that r is the distance from the origin to the point x, y that's on the terminal side. And of course, that's actually what I described to you in the drawing right before this. That's what we had labeled as r, being that hypotenuse from the origin to the point. Now, it is a right triangle, so actually your Pythagorean theorem actually applies here. It's just in terms of x, y, and r instead of a, b, and c. But you know, this would be your a squared and your b squared, and this would be your c squared. Now, this just comes from this. Like if you were to get r on one side by itself, you would have to take square root of both sides. Therefore, you would have this. Now, when you're accustomed to taking square root of both sides, you're used to the plus minus. But here, if you notice, it says r is always positive. That's very important that you remember that. R is always positive. Okay, what I have here at the bottom is referred to as Pythagorean triples. These are a combination of numbers that will always work in your Pythagorean theorem. So if you have a right triangle with sides of length 3 and 4 and hypotenuse 5, like that combination always goes together. The legs, the next one is the 5, 12, 13. So like if one leg is 5, the other leg is 12, then the hypotenuse is going to be 13. You know, and you could even read it if you know that one leg is 12 and the hypotenuse is 13, then you're guaranteed the other leg is going to have to be 5. The first two are the most common ones that you'll run across. You also see the 8, 15, 17. And of course, if you notice that the largest number would have to be the hypotenuse. Like if you see the 5 on a leg, the 4 on the other leg, the 3 is not going to be your hypotenuse. That would not be a triple, because you know your hypotenuse is always your longest side. All right, next, your trig functions and their signs. Now, I've labeled this as being algebraic signs because obviously we've got a trig function called sine. So I'm talking about the algebraic signs, meaning positive and negative. And as I said, we're going to be looking at this on our coordinate system, on your x and your y axis. So what you're looking at here is your 4 quadrants. Okay, so this is quadrant 1, 2, 3, and 4. So each trig function is always going to either be positive or negative in a certain quadrant. And it's always going to be that way, and it never changes. Alright, so what I have, these little statements that I kind of have written here in the middle of the quadrants. This first one says all trig functions are positive. So when you go make those 6 ratios that we did just a few minutes ago, every single one of those will be a positive number, a positive ratio, as long as your angle is in the first quadrant. Okay, if you go to your second quadrant though, your angle ends up over here. You know, remember this is 90, this is 180, so, you know, if you're dealing with an angle that's anywhere between 90 and 180, then you would be in your second quadrant. It's only going to be the ratio for sine and for cosecant that are going to be positive, which would also tell you that the other 4 are all going to be negative. So only sine and cosecant are positive in the second quadrant. Everything else would be negative. Third quadrant, only tangent and cotangent will be positive. Again, everything else will be negative. And the fourth quadrant, cosine and secant will be positive. And again, everything else then would be negative. Now, the little, this is like a little saying, you know, that always helps you remember things. All students take calculus. Okay, so this means that all your trig functions are positive in the first quadrant. All right, student starts with S, and what they're doing is they're pairing the S, or using the S here, because sine starts with an S. Now, I mentioned a while ago, you know, I was pointing out the fact that some of these are reciprocals, and I mentioned that sine and cosecant are reciprocals. Whatever the sine is, like SIGN of one trig function, the reciprocal is going to be exactly the same sign. So if this one's positive, this one's positive. If this one's negative, then you're guaranteed this one's negative. Okay, so the reciprocal will always do what the other one is. So here we have take, so of course T stands for tangent, and cotangent would have to do the same thing because it's the reciprocal of tangent. And then a C is for the cosine, and secant will do the same thing as cosine. So all students take calculus. And again, what I have laid out here for you is describing to you where everything is positive. Of course, if you know where it's positive, then you can conclude about where it would be negative, okay? Like for instance, sine's going to be positive here. Of course, we know sine's going to be positive here because all of them are, but then what we can get from that is that sine's going to be negative here and here, okay? I know that secant is positive here. I know it has to be positive here, but then that would mean secant's going to be negative here and here. So sometimes you're going to be asked about where things are negative, but you just kind of reason from this where things would be negative. Alright, the problems that we have here will actually help you a little bit with the all students take calculus that we were just talking about. Alright, so it says to indicate the two quadrants that theta could terminate in. So where does my angle stop? And I can determine that based on whether my trig function is positive or negative. Alright, so the first one I have here is cosine theta is equal to negative 3/7. Okay, so the thing about this is it's negative. That's what you need to notice. The fact that it's a 3 on the top, a 7 on the bottom, really doesn't matter. This could be a negative 3 over 5, or it could be a negative 2 over 7, and I'm going to answer exactly the same way. It's just the fact that it's negative. So if you go back to the note that you just finished about where the trig functions are positive and negative, let me bring it back up here. All right, so we're looking at cosine, and I want to know where cosine is negative. Okay, well, you've got to remember, this is describing where things are positive. I know cosine's positive here. Everything is positive here, so that would mean that cosine has to be negative second and third. So that would be your answer to that one. So this would be quadrant 2 and quadrant 3. Okay, number 2 is cotangent. Now, I have a decimal here instead of a fraction. I mean, it doesn't matter what form the number is in. It's just a matter of whether it's positive or negative, and I've given you a positive number this time. So I just simply need to know where is cotangent positive. Okay. So cotangent's positive here. Everything is positive here. So 1 and 3 is where it's positive, therefore 2 and 4 would have to be where it's negative. Okay, next one. So this one's still using the same note, but getting a little bit more in depth. Indicate the quadrant of quadrants in which the terminal side of theta must lie. Alright, getting a little deeper, I need to know a quadrant where cosine's positive, but secant is also, or cosecant is also negative. Now, if you can figure it out in your head, that's great. But let's just start with this right here. Cosine is going to have to be positive in the first quadrant, because everything's positive in the first, but it's also positive in the fourth quadrant. Okay, so those two quadrants satisfy this. So let's figure out what quadrants satisfy cosecant being negative. Alright, so I know it's not first, everything's positive in the first. I know it's not second because I actually have listed that cosecant's positive in the second, so that leaves 3 and 4. Okay, so I need to know the quadrant that satisfies both conditions, And the fact that quadrant 4 is listed there for each, that would be your final answer on that one.